Hello everybody, today I'm going to show you how to solve a bit higher level questions, so have a nice watching. And on the first question, ABC is an equilateral triangle. We have to prove the length of AH is equal to PD plus PN plus PE. So first I will start to combine point P with the vertices of triangle ABC. So we divide triangle ABC into three triangles, such as triangle APB, triangle PBC, and triangle PAC. And the area of triangle ABC is equal to the area of ABP plus the area of PBC and the area of PAC. And to find area of triangle ABC, we will take product of base and height, and after that we will divide by 2. So the area of triangle ABC is, let's say one side of a triangle is A, so it will be A times AH over 2 is equal to find area of triangle APB, PN times base A over 2. It is equilateral, so all sides are equal. AB is A, AC is also A. The area of PBC will be PD times A over 2 plus the area of PAC will be PE times AC over 2, which means A over 2. A over 2 times AH is equal to, A over 2 is common factor, so A over 2 times PN plus PD plus PE. A over 2 and A over 2 cancels each other out. So from here we will get the length of AH is equal to the length of PN plus the length of PD and the height of PE. Okay, it's proved. And on the second question, triangle ABC given, the sides EB is equal to side BC, ED is equal to DC, the measure of angle B is equal to 108, and the measure of angle AED is 134. And we have to find the measure of angle A, so I would like to start by combining points E and C. When we combine points E and C, we will have here is one isosceles triangle, triangle EBC and isosceles. So the measure of angle BEC and BCE will be here 36 degrees. And we get here is 36. On the other hand, we have here is one straight angle, the measure of AED plus the measure of DEC and the measure of angle CEB will be is 180 degrees. It's a straight angle. So AED is given 134 degrees and plus the measure of DEC we don't know, and the measure of angle CEB we found 36 degrees. is equal to 180. So if when we isolate the measure of angle DEC on the left, we will have 180 degrees minus 134 degrees minus 36 degrees, and we will get for angle DEC 10 degrees. It is 10. And triangle DEC also an isosceles. DE is equal to DC is given. So the measure of ECD will be also 10 degrees. We know that the sum of two interior measure will give us one remote exterior. So we say the measure of CAE is equal to plus the measure of ACE and we are going to have the measure of CEB. So on the question CAE, it is the measure of angle A, and let's say X plus the measure of angle ACE is 10 degrees is equal to the measure of angle CEB is 36. So X is equal to 36 degrees minus 10 degrees, which is going to be 26 degrees. 26 is the measure of angle A. And here is ABC and triangle AED are equilateral. We have to find the ratio of side BE to side DC. Okay, first I will extend the line from DE to the side BC. When we extend the line intersects side BC at point F. So it is 60 degrees, it must be 120 because straight angle, so it is vertical angles, it's also 60 degrees. ABC is equilateral, all interior measures are 60. I mean that the measure of angle A, the measure of angle C and B will be 60 degrees. And we know that the sum of interior measures of a triangle 180, so the measure of angle EFC is also here is 60 degrees. Another equilateral triangle. Another equilateral triangle. Okay, all sides are equal here, so let me write EFC is an equilateral. Okay, so it is 60 degrees, another straight angle, it is 120. Okay, so there is a relationship between triangle BFE and triangle CED. What is this? The interior measure here is equal 120 and 120. There are two sides such as EC and FE equal, so we can write first the measure of angle F is equal to the measure of angle E, which means 120, and the sides EF is equal to side EC, and so we will have here as two congruent triangles. So by congruence postulate we get DEC is congruent triangle BFE. So according to this, by using triangle proportional theorem, DE is equal to BF, DC is equal to BE, and EC is equal to FE. And we have to find the ratio of BE to DC. They are equal. So we will have just for ratio of DC to BE will be 1. And here is triangle ABC given, and AD is the length of the median. It is VA, and we have to prove A plus B plus C over 2 is less than VA plus VB plus VC is less than A plus B plus C. So as in the figure, Let AD be the median to side BC, and extend AD such that and AD is equal to BDE, is BA. And after that, if we combine points B and E, it follows a triangle BDE is congruent to triangle CDA because these angles are equal vertical and the sides are equal. VA here is ED is equal to DA, DB is equal to DC, so BE must be equal the length of AC, which means it's also B. And here is by triangle ABE, we know that one length is between difference others and sum of others. So we say that AE is less than the sum of BE and BA. So it will be 2VA is less than and B plus C. In a similar manner, we can find 2VB is less than A plus C and 2VC is less than A plus B. If we add this inequalities side by side, it follows 2VA plus VB plus VC is less than 2 times A plus B plus C. When we divide both sides by 2, and we will have VA plus VB plus VC is equal to A plus B plus C is less than A plus B plus C. It is the first part. Using the second figure, we can write here as for triangle ABD, and here is AD is greater than difference of AB and BD, so we write VA is greater than C minus A over 2. Of course, to do it, we have to apply the triangle inequality theorem. If I will extend the line from B to side AC and from C to side AB, we will have median B and median C. It's the same. VB is greater than A minus B over 2 and VC is greater than B minus C over 2. When we add line up, we will have VA plus VB plus VC is greater than A plus B plus C minus A over 2 plus B over 2 plus C over 2. And A minus A over 2, A minus A over 2 is A over 2 plus B over 2 plus C over 2. It is the second inequality. Using first and the second, we are going to obtain A plus B plus C over 2 is less than VA plus VB plus VC is less than A plus B plus C. For the question 5, BAC is a right triangle. AB is 3, AC 4 and BC 5 cm. Also, the measure of angle ABD is 2 times greater than the measure of angle BAD, so we have to find the length of BD. Okay, first let me draw the line from A to BC. It will be actually median. Okay, and the median intersects side BC at point E, which means AE is equal to BE is equal to EC, because we know that in a right triangle the length of the median to the hypotenuse equals half the length of the hypotenuse. So AE is equal to BC over 2. So we will have for AE is 5 over 2. In additionally, AE is equal to BE is equal to EC. Okay, it is 5 over 2. It's 5 over 2. So if BD is X, DE is also 5 over 2 minus X here. Okay, so BE is equal to AE, means that triangle ABE is an isosceles. It means the measure of angle B is equal to the measure of angle A, because corresponding sides are equal here, so it must be also alpha. And we can use here the angle bisector theorem. According to angle bisector theorem in triangle ABE, the length of AB over BD is equal to the length of AE over ED. So AB is 3, BD is X is equal to AE is 5 over 2 over DE is 5 over 2 minus X, and cross production 3 times 5 over 2 minus X is equal to 5 over 2 times X. 3 times 5 over 2 is 15 over 2 minus 3X is equal to 5X over 2. 15 over 2 is equal to 5X over 2 plus 3X. So from here, for X's, we will have 15 over 11. So what is the length of BD? It is 15 over 11 as well. And here is BAC is right triangle, CH is perpendicular to side BC, AD is equal to DC, AE is equal to EF, DF is 2 times greater than FB, and EF is given 3 cm. We will find the length of BC. And the line segment BD is intersect side AC in 2 equal parts. So we say that BD is median, and the centroid points will be on side BD. So let AK be the median to the hypotenuse BC. Okay, and here is by using similarity, BEF is similar BAG. So let's say it is X, it is Y, and it is Y. Triangle BEF is similar triangle BAG. So by triangle proportional theorem, BE over BA, EF over AG. So BE is X over BA is X plus X is equal to 3 over AG. So X over 2X is equal to 3 over AG, and AG will be here is 6 cm. G is centroid, so AG is 2 times greater than GK. So if AG is 6, GK will be 3 cm. And we know that, let me repeat it again, in a right triangle, the length of the median to the hypotenuse equals half the length of the hypotenuse. Therefore, AK is equal to CK is equal to KB. AK is 6 plus 3, which means 9. So CK and KB is 9 centimeter. So we have to find the length of BC. The length of BC is equal to CK plus KB, which means 2 times 9 is equal to 18 centimeters. Glad to have it. On the question 7, we are together with the different style question. Here is KST is an equilateral triangle. PS, PT, KP are 8, 15 and 17 units respectively. We will find the measure of SPT. Okay. So let me construct triangle SRT such that KPT is congruent SRT. Okay, it's R. So let me write KPT is congruent triangle SRT, since corresponding sides of congruent triangles are congruent, so we say KP is equal to SR, PT is equal to RT, and KT is equal to ST. Okay, so KP is 17, so SR also 17 units. PT is 15, so we will have for RT is 15 units as well. And KT is not given, so we don't need to find. Here is the length of ST. And here is, if it is alpha, let's say it is beta. The triangle is equilateral, so the measure of angle T is alpha plus beta is equal to 60 degrees. For the congruent triangles, corresponding angles are also equal. So here in triangle KPT, the measure of PTK, I mean that the measure of angle T is equal to here the measure of angle SRT, so it's also beta. These two measures are equal. So it follows the measure of angle KTS is equal to the measure of angle RTP is equal to 60 degrees, because alpha plus beta here is also 60 degrees. So triangle PRT must be here is equilateral triangle, because PT is equal to TR. It means that the measure of angle P is equal to the measure of angle R at a 60 degrees, so they are both 60 degrees. Okay? On the other hand, since the length of the sides of P R S form a Pythagorean triple, that is SR square is equal to PS square plus PR square, so 17 square is equal to 8 square plus 15 square. So we will have as 289 is equal to 64 plus 225 will be 289. We conclude that the measure of angle SPR is equal to 90 degrees. And finally, the measure of angle SPT is equal to the measure of angle SPR plus the measure of angle RPT. So which means SPR is 90 degrees plus 60 degrees. So the measure of angle SPT will be 150 degrees. Okay, we are confronted with different type of question on question 8. The triangle KLM and triangle STV given, and the area of big triangle 1008 units square, and we have to find the area of STV. If you watch my triangle lecture section, you will know that there's a formula to find ratio of small triangle to big triangle. If you can't remember, I want you to watch it again. So let's start it. The area of STV over the area of KLM is equal to LT times MV times KS plus TM times VK times SL over the length of LM times MK times KL is equal to LT is 2, 3, 4 plus 7 times 4 times 3 over 9 times 7 times 8. And the area of triangle KLM is given 1008 units square, so the area of triangle STV is equal to it is 24 plus 4 times 3, 12 times 7 is 84 over 504, and it is 1008. We can simplify by 504, it's 1 and it's 2. So the area of triangle STV is equal to 2 times 24 plus 84, which is going to be 2 times 108, 216 units square. Okay, we got the solution. Next question is 9. The area of ABC is 106 centimeters square with sides 1, 4, 3, 5, 2, and 3. We have to find the area of KLTP. It is actually quadrilateral because four-sided polygon, and I'm going to show you this part for the next videos. Okay, let's turn back our question. Before started, I'm going to describe one triangle method. What is it? If the triangles have same height, I mean that if they share common height, then their ratio of areas are equal to their lengths of bases. So what I mean to say, if I will combine point L and P, triangle BLK and triangle KLP, they share common height. So we say that first the area of BLK over the area of KLP is equal to 3 over 4. So let me say the triangle BLK is 3A, so the area of triangle KLP is going to be 4A. And for the second, triangle PBL, so the area of triangle PBL over triangle PLT is equal to the area of triangle PBL is 3A plus 4A, which means 7A, over the area of PLT, and we can see their bases 5 and 2. So from here we are going to get for area of triangle PLT 7A times 2, 14A over 4. 14A over 5, sorry. And for the third step, the area of PBT over the area of PTC is equal to 7 over 3. So the area of PBD is 7A plus 14A over 5. So 7A plus 14A over 5 will be 5 times 7 and 35, 49. A over 5 over the area of PTC is equal to 7 over 3, and cross production 3 times 49 A over 5 is equal to 7 times the area of PTC, and we can divide both sides by 7, so we will have 21A over 5 for area of triangle PTC. A over 5. And for the last part, the area of CPB over the area of CPA is equal to 3 plus 4, 7 over 1 is equal to the area of CPB will be, we found this 7A plus 14A over 2, 49A over 5 plus 21A over 5, so the area of CPB will be 40A over 5 plus 21A over 5, which is going to be 70A over 5, it is 14A over the area of CPA. And cross production, 1 times 14A is 14A is equal to 7 times the area of CPA. So 2A is equal to the area of CPA. It is 2A. So what is the total area? The total area is 14A plus 2A, which means 16A. 16A is equal to 160 centimeters square. So the A is 10 centimeter square. To find area of KLTP, It is 4a plus 14a over 5, which means 5 times 4a, 20a, plus 14a, 34a over 5. But we found a, that is 10. 34 times 10 over 5 cancels each other out. So 34 times 2 is 68 centimeters square for area of KLTP. And here we came the last question. It is 10. And we have an equilateral four-sided polygon ABCD. AB is 12, BC 15, CD 10, and DA is 5 centimeter, and we have to find the area of ABCD. As in the figure, draw diagonal BD. And form two triangles such as ABD and BCD. In triangle ABD, by the Pythagorean theorem, BD square is equal to AB square plus AD square, which is going to be AB is 12, 12 square plus 5 square will be 169. So BD square is 169, so BD will be 13 centimeter. The area of quadrilateral ABCD equals the sum of the areas of both triangles. So firstly we try to find the areas of the triangles. We found the area of ABD, so we have to find the area of BCD, and here to find area of BCD we will apply the Heron's formula. According to Heron's formula, first we will find a semi-meter as U is equal to the half of the sides, 10, 15 and 13. 10 plus 15 plus 13 over 2 is equal to 10 plus 15, 25 plus 13, 38 over 2 is 19 centimeter. And after that, to find area of BCD, we are going to use U times U minus A times U minus B times U minus C is equal to U is 19 times 19 minus 13 is 6, 19 minus 15 which is 4, and 19 minus 10 is 9 is equal to 6 to the 114 centimeters square. And we know that the area of ABCD is equal to the area of ABD plus the area of BCD is equal to the area of ABD. It is 5 times 12 over 2. What is it? Let me find here is the area of ABD is 12 times 5 over 2. It is 30 centimeters square. And 30 plus BCD is 6 to the 114 centimeters square area of ABCD. That's enough for today. Don't forget to subscribe my channel, like and comment. Have a nice day.